right here. Hopefully, should be pretty straightforward. As I said, the questions are very similar to what was on the homework. And my plan is at 1:50 to stop whatever I'm doing and hand out the quiz, and then you'll have 20 minutes to do the quiz. And then as soon as you hand the quiz in, you're free to go. But hopefully I would like everybody to finish up within 20 minutes. So what I want to do today is a couple of things. One is there was some confusion over my confusing explanation about this weird four-dimensional array in class yesterday. There's some posts on the discussion board, so I wanted to explain that a little bit. And then a big piece of this project is dealing with strings, which are a little bit confusing, so I wanted to just go over some examples and some pitfalls to clarify that. So I'm going to start off with sort of my suggestion on how to do the shell assignment. And what I wrote on the discussion board is there's sort of two ways of looking at this problem of how do you deal with sort of the string data in the shell assignment. So one approach is to parse everything into arrays. And after you've done parsing everything, take this data structure containing all the commands you have to run, and then execute whatever you parsed into the data structure. This is the one that implies using multi-dimensional arrays. The second approach is to basically have sort of a recursive program where you have a function that sort of handles each level of command. So here, sort of do one level at a time. So in the second approach, what you would do is you might take your command line So if I have my command line ls-foo, ls-bar, plus ls-baz, the first thing I would do would be to break this into sequences that end with a plus sign or end at the end. Once I have these sequences, you can take this whole string and then call a routine that says, execute this whole string of commands for me. And you know this one here is background, so you would fork before parsing this and doing anything with it. This one is not background, so you just execute it in line perhaps. In the routine to run a sequence, you would parse into commands, so you would take this and then break it up into these two pieces. And then you can call a routine that knows how to run a command. And you would just pass this entire string ls-foo into it. And the routine that can run a command would handle parsing and doing this. So then you would parse into words, call fork and exit in this routine to run a command. So this sort of breaks down the three levels you have to deal with, these sequences, commands, and then the individual pieces within a command into separate routines that know how to parse just sort of one piece of this. So the first thing you would do at the top level is say, we'll take everything separated by plus signs and the end of the line. And we'll call things separated by plus signs a sequence. When we want to run a sequence, we'll say we'll take whatever string we have and figure out whatever we have that's separated by semicolons and pass that to the next level. And this next level will say, take whatever we have separated by spaces, and we'll treat that as the words in the command. So this is one approach that people have suggested on how to sort of write the code. The other approach that I had suggested that is how I did it and other people have done is to basically do these things but then build up a data structure that contains your whole list of commands in advance. And once you have that list of commands, you can then sort of call these routines with the pre-parsed commands. You can pass, instead of passing a string into this run a sequence, you would pass an array of commands to run as a sequence. So in this case, you would do something like you would allocate a nastily deep set of pointers for your sequence. And you have to figure out how much space to be here. So you could, to figure out how much space, you can sort of say, well, how many plus signs do I have? You know, every plus sign means you have, if you have no plus signs, you need one pointer in this array. If you have two plus signs, you need one plus sign means two plus signs mean three. So that'll tell you how much space to allocate. So you then have pointers to sequences. Within here, you would then allocate an array, which is how many commands are in my sequence. And you can count the number of commands by counting how many semicolons are there in this sequence. So this will sort of point to another array of commands. And then you could say, sequence of ij equals, and here you're allocating enough space for every word, which sort of says, you know, how many words do I have between spaces here? And that says how many words I have. So this will point to an array. And then finally, you would have you can use something like stirdup. Stirdup copies a string, allocates memory for a string, and then copies a string, all in one operation. And so this will sort of create a copy of the individual word that is part of your command. And so this will sort of point to individual string. So that is the other way to solve this. And either one is equally fine. Any questions? I see you chopping at the bit.
Well, I have a question that's not about that, but let's say you got rid of the last part of that command up there.
Mm-hmm.
So does that mean that you should just be running ls-foo and ls-bar, and then, but at the same time you're able to type in commands again?
Yes.
Okay.
So a good way to test this, by the way, is to use the sleep command, which will just sort of go away for a while and then not come back. And so you can say sleep for 10 seconds or 20 seconds, and then that gives you an opportunity to very easily say, can I actually enter other commands while it's running or not? Any other questions? No. Okay. So what I kind of wanted to talk today is more about strings. The first assignment, the only string was the file name, which is pretty easy. And I've sort of touched on strings before. I want to go into a little bit more detail. So strings are just arrays of bytes, or they're pointers to memory. And it's very confusing that you can have sort of an array or a pointer that you use in exactly the same places. And this is sort of a flaw in the C language, that the designers thought this was just an easy thing to do syntactically to make it look cute, but it can be very confusing to program. And the other key piece is, as I said before, is they're null terminated. So one thing to notice is that if you have a string that is a single, this is a null character, a single null character has a length of 0. So strlen returns the number of characters, not the amount of memory you need to hold a string. Right? To hold this string here is actually 1 byte to hold this character, but the length is 0. So there's a difference between how much memory you need and how long the string is. So here's a very simple example. There are some very common, there's a whole library of string manipulation functions. They all start with str. So strcpy, string copy, destination, source, string cat says append this word onto that. So one thing to notice is, what if S was only 6 letters? I only said S had space for 6 characters, and I did a stir cat here. Right? There's nothing in this that will actually verify that your string variable is big enough to hold all the data you're putting into it. This is sort of the classic example of C not being a safe language. Java would complain and not let you do this. But C will let you do this and not complain at all. So, yes?
Is that something Valgrind will catch?
Valgrind will definitely catch this. That is sort of the purpose of Valgrind, really, is to find problems like this. Turns out Valgrind will find other problems here that aren't real problems in this code. Like, it will complain about this code, actually, even though it's totally legitimate code. And I'll show an example. Okay. So, standard thing we like to do in programming classes is ask the students to tell what are the bugs in the code, so that they'll see if you understand strings. So this is very simple code that returns the reverse of a set of the reverse of a string. So it's supposed to be the same set of characters in reverse order. Can anybody find any problems with this code? Yes.
You're only it's only mallocating the length of the string, but you need a null character.
Exactly. So if you ever want to copy a string, you need to do strlen plus 1. So that's a good problem. Anything else?
Returning the temp, which is, are we just declaring it inside the function?
So it's true, we're declaring temp inside here, but the storage for temp comes through malloc. So this is, if we had said temp was an array here, you'd be absolutely right. If you want to return a pointer, you need to have called malloc on the pointer to return it. So it's a good idea, but this in fact is correct in that case. Anything else? Yes?
We have to add a null character.
Right? So that's another problem. You're exactly right, is that we're not, the last character here will be the 0th character of I, which will not be a null character. And so we need to go and add a null at the end. Otherwise, we're returning a string without a null at the end, and then who knows what will happen. Anything else? What? Here? What should it be instead? Instead of greater than equal to 0. Well, the thing is we do want to copy the 0th element of line, right? The 0th element of line is indeed the first character, so we need to have that.
You're going to copy the null character?
Right, so that is actually the problem I was thinking of, which is the first thing we will copy is line of strlen. So if I have a 5-character if I have a 5-character array, okay, and I say, I know that it's 5 characters. Remember, this is element 0, 1, 2, 3, 4, 5. So if I say, the first thing I do is I start I at strlen, which is 5, and then I use line of 5. And from here, line of 5 is the null terminator. This means that the first character of temp is a null terminator, and so I actually have the null terminator I need, it's just in the wrong place. And so this will copy the null terminator first, and the result of what I return will look like an empty string. So, again, this is a very simple example, but, it sort of points out there's a number of sort of somewhat hard to see bugs in the code, or things that, actually when I wrote this code, I didn't even mean to write it incorrectly. I meant to write it correctly, and then I found I had bugs, and left it here as an example, which sort of shows you the challenges. Strings. Let me think. So I have. So I have the original sample code here that was buggy. So let's see what happens if I compile it. Okay, so I compile it. It all looks good. I run it, and as predicted,
We can't see it.
oh, sorry. There. I should get some duct tape here. So as predicted, nothing gets printed out. So one question is, will Valgrind find problems here? So let's run Valgrind on this command, on this program, and see what it says. Whoops. Valgrind is, I got my dot slash in the wrong place. Okay. So what does it say? It says invalid write size of 1 on line 10 right here. So it's telling me that I was writing something on size 1, and it's after, it's sort of, it's writing, right here it says it's after a block of size 13. So what this is indicating is that I allocated 13 bytes, and I'm writing something to the next byte after. I'm writing a byte, 1 byte to the next byte after that. And so that is, in fact, the problem where I didn't allocate enough space. So let's see if I add +1. Let's recompile. That didn't work. My x's. Let's see what Valgrind says this time. So now it says I'm using an uninitialized value of size 8 in the same place. So that seems rather confusing. How I'd be using an uninitialized value of size 8 right here on line 10. Let's see which is line 10. Anybody have any thoughts of what could be going wrong now? What? So what I will say is I have found, I personally don't find any problems with this code.
J's not initialized. It's not set that exact right.
Oh, right here. Let's try setting J there. Let's see. I take it back. There is a bug. Let's see if this works. Okay, so it has this weird error about some system call it doesn't know about, but it says everything is fine. So you can see, my point to get across here is that it's easy to have these off by 1 errors with strings in C, and Valgrind is your friend because it will tell you when you haven't if you forgot to initialize something. It told me that J wasn't properly being. It told me that I was using J, which hadn't been initialized. It'll tell you if you write off the end of something you allocate. So it can really, if you have a seg fault in your program or some bizarre behavior, try running Valgrind. And if you can't figure it out, you can send the output of Valgrind to me or the TA. I hope, Colin, you're willing to wade through Valgrind output. So the second thing I wanted to cover with strings is there's this question, if I have a command line, how do I break it apart into words? Right? This is kind of, you could write C code to do this, to walk through and look at every character and figure out what it is. But it turns out parsing a line of words is a really common operation. Right? Anybody who does command lines, and all Unix utilities take command lines, have to deal with this problem. So there's a C function called strtoke that does this for you. And it's called string tokenizer. And what it does is it will go through your command and break the whole string into pieces for you. So let me sort of illustrate how it works internally. Okay, so suppose I have a string hello world. Hopefully you can read hello world, there's a new line, and then there is a null terminator here. So the goal, what we'd like to know is what are the individual words in this line? And we want to use strtoke to do this. So if we say buffer is going to point to this, and then we're going to have a pointer, just a temporary pointer that we're going to use. So to start using strtoke, you pass it the string that you want to tokenize, and then you pass it what are all the separators? What are all the characters that you don't ever want to see that mean you're at the end of a word? So in this case, I'm going to use a space character and a new line. In the example up here, I also include a tab because tab is sometimes a separator. So what stirtoke will do is it will scan through this command. When it finds one of these characters, it'll replace that character with a null terminator, and then it will return a pointer to the first letter here. So temp will sort of point here. And actually, it also, if there were some spaces up here, it will skip over any spaces at the beginning until it found the first non-separator, scan through until it finds the separator, replace the separator with a new line, and return a pointer to the first non-separator character. So temp now points at this word right here. So if I did a printf on temp, it would just be hello and nothing else. The thing to note is that it didn't copy the string, it actually modified the string by inserting new line characters into it. So it means that it can be difficult to parse a line multiple times because the line kind of gets modified every time you use stirtoke on it. Internally, stirtoke has an internal pointer that it actually sets to point to the first character after the null that it inserted. So stirtoke remembers where it was in parsing this string. So to parse again, you pass in null instead of the actual string you want to parse, and this means keep parsing the string you were parsing before. Start at this internal pointer and keep scanning through this string. And so the second time I call it, it will turn word, and it will replace this with a null terminator. And then if I call stirtoke again, it will get to the end of the line and say, well, there's nothing else here, I'll just return null. So that's why a common way to use stirtoke is to sort of assign it once in the beginning outside a while loop. While it's non-null, scan through, and actually print out the individual results. Yes?
So like in that example, if we had hello world, so then the first element of commands would be hello, and the second element of commands would be.
Okay, so here is my sample code. This is a little bit more like what you'd want in a shell, in that it reads some standard input. So I'm going to read a line of text from standard input here up to 100 characters. I'm going to call stirtoke, and I'm going to have this while loop. This is the while loop that I just showed you on the PowerPoint slide. So it's going to look for a new line, space, and a tab, and then when it's done, it's going to print out all the words. So let's just see how this works. So if I type in these things, it parses everything nicely. So one of the nice things is, if I put in lots of spaces in the middle, it's very smart about getting rid of all the extra spaces and skipping over them. So it definitely sort of knows what it's doing. So let me just do one more thing. I'm going to fire up GDB and actually use GDB here. And I'm going to break right before I print everything out. Oh, sorry about this. Okay, so I'm in the debugger. And if I print out commands, remember commands is an array. If you remember what the code looks like, I'll just switch to it briefly. Commands is an array here of pointers. So when I print out commands, GDB is going to print out, here's the address of the first pointer, and then it's hello, and the address of the second pointer, and then hello. If I print out, what was it, buffer. What you can see in buffer is that you can see where stirtoke put in the null terminators. Right here, these 000s indicate that strtoke put in null terminators in the middle. Was there a question over here? No. Okay. Yes?
What was the T in the argument?
T means tab. So if somebody hits a tab, so in my example, if somebody hits a tab character, we treat that as white space and ignore it as a separator. Yes?
So, what happens if you want, let's say you have a long line, and at the end there's the plus, right?
Uh-huh.
So if you do a strtoke with the plus, you're going to get what comes before it, but also if there was no plus, and you strtoked on plus, it would chop it off at the new line, right?
Right, so if I
So
had...
how do you tell the difference between it being, or do you have to do upfront work?
So we have a column where there's hello, and then we have plus as a separator, and then world, and then the new line. And if we do a strtoke on plus here, what will happen is that it will replace this plus and say here is one line, and then here is the, here's one word in the next word. But it doesn't tell you is there a plus at the end of this word or not a plus. And you actually need to know, because it depends. So you actually, in this case, you actually have to scan backwards and find if there's a plus at the end. Strtoke assumes you don't care about whether it's there or not. So you actually have to figure that out. So there's another critical problem with strtoke, which is, what if you have a loop okay, so my code is a little messy here. But so suppose I want to have an outer loop that is doing a strtoke on a plus, and then I want to have an inner loop that does a strtoke on a semicolon. So actually, let me. Okay, so maybe you can see the code. Strtoke on plus of some string while temp. I'm going to do a strtoke on temp itself and look for semicolons. And so my idea is I'm going to, in one nested loop, I'm going to both break this into sequences separated by pluses and then break the sequences that have each sequence, I'm going to break it by semicolons. This is going to totally fail. And the thing to remember, it doesn't matter if this isn't a function that you call, it doesn't matter or not. The fact is, if you have a loop where you're using strtoke and you call any function using strtoke, bad things will happen. Can anybody identify why?
It might be the same instance of strtoke.
Right, so it is. The problem is, there's a hidden global variable here, this internal pointer that points to where it is in the string. Right, so if you call strtoke again, it resets this internal pointer. So when we called strtoke here, we set the internal pointer to point to the end of the first sequence. When we call strtoke here, it resets that internal pointer to be someplace else. To sort of, because we're now looking inside temp2. And so this will mean that you will never find, usually it means you never find more than one thing in the outer loop. Because the inner loop kind of resets things, and it thinks that the string actually ends at the end of temp2 here. So the lesson here is no nested loops with strtoke. So that code example where I showed, well, take the parse for pluses and then call a function that does parsing for semicolons and then calls a function that does parsing for spaces. If you use strtoke and you actually do that as functions, your code won't work. So what can you do? Back.
Could you make another buffer and copy from there?
So the problem is, the problem is not so much that you're working on the same piece of memory. The problem is this hidden internal pointer that keeps track of where you are. So there's, you have a suggestion?
Yeah, do the, so here you trend the stir token on the plus, do all of that at first,
Mhm.
and then for each item that you have, then go through and do that loop. for
Right.
each.
So one option is, instead of doing this loop here, down here I'll say, you know, build up an array of all the sequences that you find, and then when you're done, do your second parsing down below here. So do sort of completely parse at one level before you start at the next level. That is one option. The other option is there is a function that solves this problem. It's a little more confusing. It's stirtoke underscore r, I believe. And what stirtoke underscore r does is this internal variable is no longer a variable anymore. So in this case, if you want to use the underscore r version, what you do is you pass in a character pointer that will be used to store this internal variable. So it's not a global variable, it's just one of your variables. You pass it in, stirtoke will set it for you, and then you can have this nice nested structure, and it all works out. So if you want to learn more about it, you can see I have the man page up here that sort of shows how to use it. I guess they call it lasts in this example. It also suggests using the function stirsep as a way to do this, but that's probably too young for me to know about. Okay, so hopefully this has been sort of a whirlwind. How do we get started? I now really want to get to the quiz, so you have plenty of time to work on it. So what I will do is just sort of hand out a bunch to each row. This is a closed note, closed book quiz. I'm guessing how many I need. In the back row, so we'll get started here, and then I'll get the exit on the other side and bring it back. Are there any extras? You guys need a bunch too, What? Start? You can start. You still need one?